Now I know what you're thinking. A third video? How could there possibly be 3 videos of unethical things? Oh no, there's lots more left. An example from the intro class. You're comparing 2 different means. You want to prove, I don't know, the group B is better because it's on some medicine. And your alpha is 0.05 and your p-value comes out to 0.06. That's going to be failed to reject. Well, failed to reject often isn't published. In fact, they make fun of the fact that nobody publishes non-significant results. So how do you fix this? Easy solution? Let's just not have this answer by changing our alpha zero point 0.1, and now suddenly our p-value is significant. And you might be thinking to yourself, the difference between a p-value at, 0.049 and 0.051, they're not actually that different, and yet you're going to flip which conclusion you make based off that? And the answer is no. A good statistician will say, okay, the results showed a p-value of this. It's the wording you've got to be careful of. When you're getting close to 0.05, you're not going to say, we have shown or we have proven, but maybe there's a suggestion or the data thinks this might be, and the higher that p-value goes, the more you're going to say we can be a little less certain about these results. And if you're reading other people's research, look at the alpha they're using, and then look at the wording. How strong are they saying their conclusions are? Here's an example of a guy that this actually happened to. His p-value was 0.08, and he got in legal trouble. Lost his job, and look at the reason. If he'd have said suggest rather than demonstrate, he would have been okay. Wow. Really? I'm not sure we need to be so nitpicky about the wording we use, but people are worried about unethical data science, and changing the alpha so that you can make the conclusion you want is one way to be unethical. And it kind of seems to me like this guy was made the example to scare everybody else into being careful with their wording. Let's talk about ethics related to the people who are paying you to do this research, the people who are expecting you to do a good job. And of course, a lot of these categories really mesh into each other. Here's another example of an unethical action where you do a semi-attached figure. More doctors smoke Camels than any other cigarette. Well, if you surveyed doctors, you would find some who smoke, and you would find some brand that is the most popular. Does that mean that doctors recommend Camels? No. In fact, most doctors probably don't smoke. But by connecting doctors and Camels, you think, oh, these cigarettes are healthy. That's trying to get people to connect to things because you talked about them together when there really isn't a connection there. This is related to the Simpsons paradox, all right? You have a pattern or a relationship, but when you look across groups, it changes to be a different pattern. This was actually a common one with Obama in his election because they looked at the ages of people and whether you were more or less likely to vote for him. And then they also looked at groups such as college age and adult. Anyway, the point was the older you were, the more likely you were to vote for him. But if you looked across the data, it seemed like older people were less likely. The Simpsons paradox is something that's talked about a lot. The basic idea is how you break things up and how you get your groups can color how things look. Here, millennials seem to be getting a lot less of one or the other just because there's fewer millennials that need that kind of an operation. This one came out when I was a kid. November is the month when most serial killers are born. I had a friend whose birthday was in November. Of course, there's some month that is the most common. It doesn't mean anything, it's just random noise. The topic of extrapolation has been an interesting one ever since the pandemic because everyone had these predictions of what was going to happen in 2020, just totally threw the book out. And now people are still trying to predict, and since no one's pulled out of a pandemic like this before, it's really hard to figure it out. Extrapolation isn't necessarily evil. It's a normal thing to do when you're trying to figure out what's going to be happening next. You have to understand it relies on the assumption that things are going to continue with the pattern that you put on the data. This does mean that if you wanted to get a certain prediction to make certain people happy, find a model that has a pattern where beyond the data it goes wherever you want it to. If you're doing that on purpose, yeah, then that would not be ethical. Is there any ethical way to do extrapolation? Possibly not, and there is value in being able to extrapolate or at least try to predict the future. So there we go. Sometimes it feels like there's no good ethical choice, but your duty is to try to find the best one. What made you believe that was the right model? It really should be based off your statistical expertise, not what other people want to get. This is a real ad I actually saw in I can't remember now where, it was somewhere back east, but 6 times more likely seems really exciting until you realize there's a small chance beforehand. So you take 0.0001 times 6, 0.0006. Do you need to worry about this? Well, okay, the purpose of what they're saying is race is actually an important part of this, and you need to check for, stroke, whatever else. It's not a bad sign. They are kind of pushing the numbers. Look here at this table. If you subtract these and then subtract the two groups, or if you divide the numbers and then subtract the two quotients, or if you subtract them and then take the products, I got all these different numbers by taking different combinations of these four values. 3.5 times more likely, or a 4% increase. I mean, whatever number you want, you could find a way to twist these. And relative risk, odds risk, probability, people don't know these terms well enough to be able to figure that out. This is absolutely a form of trickery that happens a lot. Play with the numbers to get something exciting, and let's report that one. If it's the odds or if it's relative risk, whichever one happens to give us the better results. If your goal is to scare people, I get why you're doing that. Is it unethical? It may not be illegal. If your goal is to educate people, then you're going to do something more clear. If people don't know what the word odds means, then don't use that. Find a way to express what you're trying to do in such a way that someone can understand it without having taken an introductory stat class. Here's an example of 100% growth, and I'm not going to go through the comics. You can pause the video and read them if you need, but 50% pay cut and then 50% raise, they're not the same thing because it's 50% of the base amount we're talking about, and that matters. Here's another funny true story. Scientists found that there was a specific gas that affected the cell wall of certain types of cancer cells. Time publishes Smelling Farts Prevents Cancer. Now, to be fair, the magazine actually printed a retraction in this case saying, yeah, we took it too far. But this is something really common where somebody does a high-level research thing that a normal layperson wouldn't be able to understand, and magazines will publish their version of it, and it may not come out right. It's certainly a case of where, in this situation, Time magazine was being unethical, but scientists themselves, if they want to simplify it and make it exciting, might have a tendency to do that. It's better to take more time to explain clearly what the truth really is instead of doing something, exciting like smelling parts. Did you see the part right here? You owe the smelly guy in the subway a thank you? Really? Let's talk about the ethics related to the people in your study. So these are, your data points. People talk about weird, Western, educated, industrialized, rich, and democratic. This is where a lot of studies are done because this is where it's easy to get a lot of people in your study. But if you're wanting to understand, the Earth or the human population or the science related to human biology, you're not just going to people of the same race or the same, cultural background. Rich can be an effect for lots of different things. Democratic, oh, that's misspelled. Darn it. Ah, the power of the pause button. Let's talk about censored data. Here we have dark blue data, that's the real data, and then the light purple is what we actually get to see. So all these data points here that were before this line get censored up. So we don't know how far back they were supposed to go. If you do regression on the purplish color, you're going to get a line that looks way more steep. Why? Because these data points are suddenly shoved up here, and that's more steep than the original. This is going to bias your results. There are methods for handling this, finding a probability distribution, and these guys get weighted differently. Now, if you see that your data is censored and you don't account for it, that's unethical. You know you're getting biased results. Go look up how to handle censored data. We're not going through it in detail in this class. Let's talk about the issue of having missing data. This comes from some research I've been involved in. They were looking at Chinese American children and their weight, and some places did not record the weight of a child, and there's FERPA laws, you can't get it. So you see all the data points, but some of them have been grayed out because you don't get to see them. Now, in this case, measuring weight, it was usually the fatter kids who did not want their weight Fatter is fatter an appropriate? I looked it up online. It says the correct term is robust. So my apologies if that was offensive. The children who were robust tended to not report their weight, and so your average is going to be down. Not the regression line, interestingly enough, but if you don't account for the missing data, in this case, you would know the X values, you just don't know where it lands on the Y values. And we'll actually go in detail on some ideas of how you might handle this in a later video. Last topic for this section, confidentiality. It's a big deal, and you need to know what the people in the study need, what you've told them, what your expectations are, and there's legal consequences that can come from messing up on confidentiality. Case in point, MD Anderson, guy had his laptop stolen. No one knows if anyone actually managed to get into the laptop, decode his data, or actually look at the records, but it doesn't matter. It was a breach of security, and you can see the amount of money that it cost up there, which is huge. If your study is going to have sensitive information that could be damaging to a person if it gets loose, you have a moral obligation to guard confidentiality, and if you told people you're guarding confidentiality, you're legally obligated to make sure that you follow through on those sorts of things. That's part of the IRB, meaning the special form you have to fill out in order to work with people if you've got some sensitive information. This one is interesting though because here's a guy who did not agree to be part of the study, but his parents did because it was working with babies and children. How do you handle this? Are we going to say we can't do research on babies? That may not be the right move because some things need to be done when you're talking about genetics, but this of course ended up being unfortunate for this guy, and it was because somebody else agreed to it. And look, I'm not going to say I know the answers to all these, but an ethical data scientist is going to carefully consider these topics, and when you do your grant research, talk about them clearly and fully, and then make sure that you stick by the rules that you are legally allowed and the things that you tell the other clients.